Subfields, we did that last time. Now we're just cleaning up here, so I just think we're just gonna show the process of what I'm changing due to um, due to me having a different idea of what we should do. So this is basically what we're doing, and I think I made this when I was high school, so some of the questions are so goddamn awful that I have to change them. Equal, what was it again? 11. It's 12. And then this would be A equal 12. I like A better because A, B, C is what the convention is. So why the hell did I choose C? I was in high school and thought that C was better. Although breaking convention is the norm of a textbook because otherwise you have the same shit everywhere. So that is called a right triangle. Um, yeah, that's pretty much what we're doing all the time. I'm doing all the time, looking at the previous question and just say some of them are shit, we throw them away. If they're good, we keep them. Um, for the Pythagorean theorem, I thought there would be a lot more, but there's actually a lot less to put than I thought because I, as high schooler, used this continuously like hell. Um, but now that I'm seeing this, this should not be its own section. The only reason why it was its own section because I remember in high school I used this a lot. Um, funny days I remember. But in college, it really doesn't really matter, I don't know why this is its own section. What this should be in, my personal opinion, should be a subsection in geometry. Now I can delete all that. Let me delete all this because I actually think that this much information is enough for Pythagorean theorem, and this should not be its own section, in my opinion. So it's gonna go under geometry, and then it's just gonna be on the top of it because it is important that it can keep someone entertained, but it's definitely not header two material. It's more like header five material. Like yeah, it's worth checking out, but it's not something. So oh my god, fixing this up will be a pain in the ass. Graphing time fixing is gonna be also a pain in the ass. Yeah. There's a few things I want to put in here that would change this question immensely, but a lot of work um, gonna be needed to change this shit. Oh, I remember I making this that was a pain in the ass. Ugh, I can't wait to redo all the shenanigans. Alright, yeah. This was. Oh, I remember this. This was weird. Oh, these questions were awfully weird. Oh, well, at least we fixed that portion up. I mean, it deserves to be fixed eventually. Oh, I did fix the basic log also. That was a weird thing. Um, there's a few questions I want to talk about. One is the imaginary movement. So when we did the question like 10x minus 5, did I really choose 5? Well, there's no way I don't know. So you obviously have to choose 2 points, so negative and then the positive version of it. But that's not really the official right answer because this can have imaginary solution and it can have almost infinite imaginary solutions. Um, yeah. So this is the real solutions. One real solution was available. Really? Really? No, no, there should be two oh, oh, shit. I think this copied and pasted the wrong one. Well, then we can redo this very easily. Um, why I know there's two solutions because the imaginary solution wouldn't work without having two solutions here. So this is technically wrong. I cannot believe I oversight this. I need to double check all my math here. Plus minus. Minus 10, that's 10. 10 over here. Um, this is minus 1. And then, oh, this is going to be pain in the ass a little bit. Okay, so I did do something wrong here. We'll admit that to a t. So this is actually supposed to be here and there. This over here too. Then this is somehow still correct. No, this is 20 over here. And then this is negative 4. Negative 4. Okay, so this. Okay, so let me just change this to this. Then we can easily fix the whole. Did this? Yeah, this is. So this is negative 10, negative 15. So this is 15. So 15 equals 15. So we can just change that to 15. Okay, so this is negative 4. That's negative 40. Wait, that's wrong. So wrong. 45? No, something's wrong with this one again. So that's plus 20. Here's 10. And then this is supposed to be a plus here. Oh, that's 2. 2 over here, 20. This is supposed to be 20. And then this is supposed to be 15. Because I know that this must be true. Because this is true. Therefore, the answer is true. Let me check the other ones too. That they're, at least from the outside looking in, looks about the same. Oh, this has no real solution. You can't really have a negative, can you? Um, yeah, everything else looks correct. And then this one I definitely know is correct. And this was a little trickier question. Um, but if you looked at the imaginary cannot be canceled by wheel, so this must be 0 over here. Um, hmm. I think we did that in polynomial part 1. I explained here that imaginary cannot be cancelled at 0. It's good to explain it back again. Do I have enough space here, although? I don't think we have enough space to explain that imaginary can be only cancelled out by imaginary, and real can be cancelled out by real, unless absolute value. Who knows? Hmm. We'll see. So why this has more than if it was an imaginary world, if it was a real world, this is enough. The solution that we had here is a-okay. Um, oh, I realized we double dipped here. I did not know we double dipped. Just fine. So this is completely fine if you don't consider imaginary. But there's few ways to do imagined numbers. So let's do one way of doing it. So you do this over here, and then equal 5, 15. The problem with this is that you have a minus 5 and a 10, so you're going to have to do a little bit of soul searching to get the right answer. Huh. Okay. So 10a minus 5 plus 10bi. This is what you have to do. And then what you have to do after that, if you were doing this method, which I don't recommend for this one, but since I'm doing it, I use this method later. So anyway, I get rid of the I, which is the right way to do it, right? Oh, is it just plus? I don't remember how to do it. Yeah, it's actually plus, so I'm wrong. Okay, where is this one? I was thinking that because it's like this, and then this is imaginary, and this is real. And then it's like this. There's actually a distance between these two that we have, but it's imaginary worlds has a different dimension, as people would say. Um, it's like wrapping yourself in many coils. So if you look at the imaginary world, it's like a panorama where you dip into this space and come out of it. It's like a rotational like gear if you think about it. So then you will have to do something like um I really don't want to do that too. 10a squared, so that's like 100, right? 100a squared, and then this would be a square root of all cost. If you're doing this method, I don't recommend it. Um, Minus 100a because it is this times this plus 25, right? We get that plus 100b squared, and then equal 15, and you have to find a and b, a and b. Now that's very hard, very hard, very hard, very hard, especially with no information given to the contrary, and I don't think it's actually possible by the human eye. So what you have to do in this situation is use Euler's formula. Now, what is Euler's formula? Well, if you change this to this, ei theta, what happens is you're sneakily adding a z component. You're basically saying, yeah, I know e of theta equal um, cosine theta plus I sine theta, which I don't think I teach you this, and yet I don't think it's part of this lecture. Yeah, no. Um, yeah, I don't think I did. Fuck. Um, well, why not just add it here? Just say Euler's formula is equal to cosine. Into the equation. Oh shit. I'm not worried as long as I go back like that, then you're fine. Thing, and then we X this out a little bit. There's nothing wrong with it. Insert new equation. Alright, parentheses, they failed, good. Insert a special character. Now, is this the right one? I hate that one actually, looking at it. I think I have to use this one. Yeah. I know what? I don't like that one. Why is it not the same? I have no idea. Whatever. Okay, there it is. If you do it that way, um, what happened is maybe my eyes are tricking me a little bit. You're. I'm very sleepy. I'm sleep deprived as hell right now. So something like this is happening where you can represent a movement in a circle with this clause. what you have to do is that this theta is like a x or y. It's a movement function, basically. And if I do plug into decimals, I can't do that because imaginary doesn't exist in this freaking calculator. I forgot. How am I gonna do this? Because I put these x plus sine these x. Can I do I here? No, I doesn't work. And square root of -1 won't work here, right? Okay, it does. Let me. More options. How the hell do you do it here? Oh, you want to see Fourier series? Is this Fourier series? I don't remember. Ah, Fourier series. Oh, share. This is awesome. I love Fourier series. Look at that. That's so cool. Uh, oh, deleted by accident, whatever. Anyway, now what this does is this, and then that means it secretly hides bi here. It basically hides an a and a b, and then hides it off into this immaculate formula. Now, what you do here then is 10x equal 15 ei theta. Hiding the a and b as a theta makes it more easier to comprehend what I'm doing. And then you divide everything by 10, which gives you 3 divided by 2 ei theta plus 1 divided by 2. And that's the real answer. Now, if this formula is true, if you want the real value, notice that if theta equals pi or 0, this turns to 1 while this turns to 0. So what you literally have to do is when this is 0, oh wait, cosine is -1. If this is 0, wait, do I explain cosine and sine this early? No, I don't. Well, this is something fun for you, but equals 1. So x equals 3 divided by 2 for real functions. So what I can say is x real equal 3 divided by 2 plus 1 half, which equals 4 divided by 2. And actually, let me just get rid of this. And 3 divided by 2 minus 1 divided by 2, which equals 2 divided by 2, which equals 1. Wait, did I do this wrong? I did something wrong. It's negative, so it's 4. So this is -2. And then this is +2. But it should be the same as up here. Wait, did I do something wrong? I did something wrong. Oh, where did I do wrong? The 2 is correct. Oh, this is wrong. This is a plus, so this is 2 divided by 2, which is negative, which equals -1. Okay, good. We got the same thing. I just fucked up the algebra. Sleep deprived or anything, whatever, it's my fault. Yeah, I know. But if it's something like here, you can still get some output and input. Yeah, because this is going to be a square root of something. Now, what does this do for us? Well, my friend, let's just say we had some input like this. Um, let's just say we have an input. Because x is just input, y is usually denoted as output. Now, imagine you have some transformer, maybe a LTI, and we want the output with a convolution. Um, it's a bad example. I don't want to do the LTI with the imaginary numbers and fuck everything up. That would be like fucking stupid. Let's baby it down a little bit. because imaginary number sucks, and I don't want to deal with shit like that. I don't want to deal with shit like that. They're still here. There. I don't know. I don't want to deal with that. So why don't we plug this into an equation instead, and then let's get out two output, right? Do I want the two output, or maybe why don't we just get one output, and then we can also do a two output system. So if you, and then that would be three outputs together if you wanted to do that. Okay, what I mean by that. Now, but they have to be linked outputs, so all three of them are linked. It needs to be a system that wants all three of them to be that level of linkness. But we'll see how that turns out. I don't think we need it will be something like that, but if you need it. So if I was to do absolute value with some plus or minus or some convolution or something, um, by that not convolution, by delay or output or something, um, or advance. What you could do in this case is do something like x in here, and then we could just do plus b plus a. Oh, no, well, they're taken, so let's just do plus e. Now, what does x do? The absolute value would turn this into real, right? Purely real function, and we'll give you output. Oh, purely real function, and e is actually taken as a special thing, so you shouldn't use e. Let's just say that we just do absolute value there. So absolute value, we get a purely real function, and it's the magnitude of this thing. Um, so what you would get is the square root of something, blah blah blah, whatever. You would get a and b over here, right? A plus b, I, then you get square root, and then square, to get rid of the I and square. So you will get sine, cosine, um, times by 3 divided by 2, and possibly plus 1 divided by 2 somehow. Uh, in one way or another, you would get that. Yeah, I think you would get something like that. I don't know. Oh, yeah. You would definitely get something like that, and then plus a half will be added to the cosine, and that's what you would get. So you get a purely real function that is the magnitude of x. For this um, absolute value x, I think it'll be more complicated if you were actually to do this, but like an LTI or something like that. Now, if you were to do this path, what would you get? Now, this is purely plugging x. You would get a and plus bi. Bi could be something and a could be something, so there's two outputs. Therefore, you have three outputs. There. For one input, you have three different outputs. Which, thinking about it, is very, I mean, it's very substantial and very useless. You're gonna have to do a lot of shit to actually make this work. So this is a very useless system. But you get the general idea of the power of imaginary, where you can get multiple inputs, no, multiple outputs with one value. You unplug something, you get three outputs or two outputs or whatever. That's the power of imaginary. Um, so don't slack on imaginary. I know I slacked on it. I thought it was the fucking dumbest shit in the world. Until I learned LTI and until I learned Fourier series, until I learned Laplace transformation, frequency response, and all that bullshit that comes with imaginary domain, also with the integrals that are impossible. What I mean by this impossible integrals is that it basically makes the integrals burgers. It makes the integrals mm, oh, cookie too. Um, it makes the integral possible. There's some few impossible integrals that can only be solved by um, the imaginary method because it loops around to itself. What does looped around itself mean? It literally just loop. That's literally all it means, which is a powerful method, understood. Very powerful. And then let me just delete this because I don't know. Actually, why did I delete that? Yeah, because I want to use space. The I is like a vector that moves around. So if you do some limit. So like something like ln, and by the special case of ln where you have something like this and you have something like this and you're trying to get this area over here, you're not sure if this is finite because of this. You could use this I method because you can get the limit of this over here. The negative side or positive side wouldn't matter because it's the same direction, and then use the I method to confirm that. Uh, and this will tell you that there is a limit. Yeah. Um, there's a few other circumstances that are actually a lot of circumstances that I would use this, but and that is useful. But I don't know if they're practical in real life. You know those things. Imaginary is very useful for control systems. Okay, for aerospace engineers, this is like, mwah, I think, because I need to take another class of this shit next quarter, and I'm gonna kill myself on that one. Ugh, I hate doing this shenanigans because they're such a pain in the ass. I mean, doing LTS is fine, but once you know that it's like a bunch of this thing, it just becomes a pain. I mean, I don't know who created it, but they must have been a genius or something. Uh, yeah, I guess so. But oh yeah, 4 years, right? 4 years. Fun. 4 years. Someone named 4 years did that. What a weird name. Anyway, yeah, that was a pain in the ass, and I feel so sleepy. Even discussing this, and how much time do I have left on this thing? I don't know. It doesn't show. Oh yeah, 27 minutes. I'm gonna stop here. We can do something else. I don't think we have anything else to talk about because this just took forever for me to explain that there's multiple in one input can give you multiple outputs. Um, So it also has a BIMO stable. You can probably make a matrix and a BIMO system where you have a matrix, a B matrix, C matrix, and D matrix, and figure out the integers and solve it. Yeah, you could totally do that, can't you? This angers me a little bit because it's hard to comprehend that logic. You could definitely do that. I'm not joking about that. You could definitely do something like that. Well, you could also probably do something like that. I never thought of it. I'm just thinking about it now. Huh. I wonder how that class that would be. It would be very interesting to do that. Huh. Yeah, I don't really like control systems, but now thinking about it, control systems are awesome. Hmm. Well, that's a that's interesting. That's very interesting. Huh. Huh. Interesting. Yeah, I definitely think it's interesting now. Never thought of it that way. Oh well. Anyway,